Space technology, chemical industries, high-performance computing, science and technology, energy transition. AI possesses the encompassing potential to power up the materials and energy sector of the country. AI-driven solutions are used to optimize both renewable and traditional energy systems all over the world. In the renewable energy space, AI assists in the site selection for solar and wind farms by analyzing geographical and climatic data, ensuring that installations are placed in optimal locations. Government agencies are looking into tapping AI to detect issues in the energy grid, to prevent outages, and ensure smooth operations across power plants in the country. These developments illustrate AI's potential to revolutionize the energy landscape in the Philippines.
There are many areas I can highlight today about energy, materials, and manufacturing. So I'm with University of Tennessee, but I'm also a group leader at Oak Ridge National Lab. In fact, I maintain two positions, basically. As a group leader at the National Lab with the Department of Energy, we work with neutron scattering, but also a lot of materials research that are based not only on nuclear energy, but everyday things like plastics or polymers. And in fact, University of Tennessee is a center for polymer research and materials as well. The research that we do in our group, I'm still a professor, is in the area of nanomaterials, nanostructuring, synthesis of polymers, and lately, as I'll explain to you at the end of this talk, a lot of advances in AI and machine learning that we bring to chemistry and additive manufacturing. And also to highlight, the University of Tennessee is really the center, one of the centers for nuclear energy, science and engineering. It has one of the oldest programs in granting degrees in nuclear engineering, one of the broadest in terms of scope, but in terms of ranking, we only rank second to MIT in terms of training future engineers, scientists in nuclear energy. In fact, Oak Ridge and Knoxville is considered the Silicon Valley of the nuclear industry. So I welcome you to explore the opportunities we have, especially as the nuclear energy is one of the clean energies, and the Philippines is set to adapt that as well with other countries. So I'd like to start with this slide because as a scientist, I like to discover things. I like to publish and train PhD students. But on the other hand, I also want to contribute to society. And this is a perspective that comes from, let's say, Pasteur. So Niels Bohr, who played a very important role in the theory of the atom, of course, is a fundamental scientist. And you would say that Thomas Edison, who's famous for saying that invention is basically 1% inspiration and 99% perspiration, okay? But yet he founded General Electric, and he contributed many of the practical things that we do. However, we don't reasonably think about Pasteur. Well, how many of you drank pasteurized milk this morning? How many of you used Pasteur pipette? How many of you had vaccinations? That basically is a start of things that Pasteur did. And of course, as a chemist, I know my left hand and right hand mirror images. So he is a passionate scientist from France who actually contributed a lot to fundamental science and also to the society. And I find myself looking introspectively where I might bring my science to the technology of tomorrow. And that's really what AI and machine learning has done. So actually, in 2016, when I gave this talk at the World Economic Forum, I was talking about additive manufacturing, aka 3D printing. So when you think about a 3D printer, it's a type of manufacturing process that is digitalized, but at the same time, as we are going into the foray of AI and machine learning, something that can be perfected or optimized in terms of applications. From inner space to outer space to biomedical engineering, bio-inspired design, we are finding more and more additive manufacturing in society and industries. So actually, there are many applications, not only in automotive, marine, biomedical engineering, space, okay, 3D printing, prototype satellites. A lot of this will require materials or different types of materials based on plastics, ceramics, or even metals. So actually, 3D printing compared to other manufacturing processes like injection molding or milling has a very important advantage. It thrives when you have complexity of design, convergence of function and format, as well as high performance in material. So when you find this convergence, additive manufacturing is really the solution. So actually, in 2014, when I started 3D printing, we focused on the use of nanomaterials. Nanocomposites enable, with very little addition or additives as little as 0.1%, can double the tensile strength, the storage modulus, the barrier properties of materials. So focusing on materials research, we were able to demonstrate that this high value adding of 3D printing and materials is possible. And along the way, we trained a lot of students, PhD students, as well as visiting scholars from the Philippines. This was the time that when I was still a professor at Case Western Reserve University. So this is a very recent picture. Prior to coming here, just 3 days ago, I was in France. In fact, I was traveling with my wife, and we ended up passing by in Normandy, France. We took this picture of a World War II Jeep. This is an actual World War II Jeep, last produced in the 40s. And they were roaming around Europe, almost 1 million of them, okay? And very few original pieces exist. So this is an original Jeep. However, we can 3D print them. So this is a 3D printed Jeep by Oak Ridge National Lab. It was 3D printed in record time, 6 months. And 3D printing here, in this case, resurrected, if not reinvented, the manufacturing of Jeep. Although not as fast a scale as in World War II yet, 3D printing lies in digitalization of or remanufacturing of old equipment or very important capital, which I hope the Philippines will find an industry to recapitalizing old equipment by repairing them with 3D printers. And so a story that I often shared is how Additive Manufacturing Center, or AMCen, which was started by DOST several years ago, is a true center or pride of the Philippines. We're only second to Singapore in terms of having this national center for 3D printing. And a lot of this, I helped during my time at Case Western Reserve University, train, form the concept, and establish the printer. So in fact, if you have an opportunity to visit AMCen, you will find a lot of 3D printers there, demonstrated technologies, and also, if you go to the administration site of DOST, you will find a statue of Rizal. And this was in celebration of his birthday. And this is a record, maybe a world record, perhaps in the future, but this is made of plastic, okay? 3D printed statue of Rizal in plastic. This is about 10 feet long, tall, no? So you can see the power of 3D printing in many industries, including creative sciences. And in the future, you will see that manufacturing will rely more and more on digitalization based on 3D printing. And this is really bringing value to even traditional supply chains. And in combination with AI and machine learning, you can supercharge 3D printing because you'll be able to make a lot of case studies, optimization of processes, and the use of indigenous materials. Imagine if a lot of the materials that are locally produced in the Philippines can be optimized for manufacturing with the help of AI and machine learning, how it can transform a lot of industries and supply chains towards not only local but also export. So let's talk about AI. Maybe some basics here for some of you are new. AI, or artificial intelligence, as mentioned earlier, you will find it in many applications. Non-science or non-engineering, finance, weather, satellites, space technology. But in particular, I'd like to highlight applications in science and engineering. In fact, this is not new for a scientist. This year was a fruition of that because of the Nobel Prize winners in physics and chemistry. In particular, the Nobel Prize win in physics did not highlight AI. It highlighted what we call machine learning, ML. And a lot of the algorithms, a lot of the practices found in data analytics and generative learning has many fundamentals. And not only in physics, but also in chemistry. The Nobel Prize win in chemistry relied on using AI and machine learning to perfect the design of proteins. So you can see a back-to-back win for AI and machine learning in the realm of science and engineering. So as a scientist, you are actually practicing machine learning. Sometimes we call that statistics, okay? Design of experiment, matrix design, you are doing machine learning. However, we only hear about AI. Machine learning, as Joel explained, is really where the rubber meets the road, where you try to optimize, perfect the application. So at this point, I want to highlight now, and maybe again and again, it is not the AI that unlocks the value, it's the machine learning. It's the ability to apply AI in a real-world application, which I believe is going to be the key for growth in the Philippines. You need to find case studies, uses, unique solutions that can be solved by applying machine learning. AI, or a true test, is really trying to distinguish it from the real thing. And sometimes you have to use algorithm. Generative learning to make more complex tasks and relationships simpler. And that is where you use neural networks. Neural networks, again, if you trace it, in fact, it's very interesting. It's actually, its origins is based on psychology, okay? The mind, the heuristics is how you try to make the mind work so that the mind, the human in the loop, can be transforming in terms of computational methods. And one thing you can rely on, which is available today, is simulation. Simulation, digital twins, ability to compute, the ability to model or make your ideal cases, ideal results is something we can even do in the Philippines now, because you need a lot of computational power, a lot of skills to make those layers and layers of neural networks or algorithms that is based on hard science, physics or chemistry. So this is a very nice chart of where machine learning lies. You see, you need data. You need your initial data, or you need to build what we call large language models. So what, for example, the space agency can provide is data. What you have that data is that you need to use an algorithm. You need to use a formula to make it useful for your application. That is your algorithm. So together with your initial data, or data you derive from large language models, you use your algorithm, you do the experiment, or where the rubber meets the road, and then you do a feedback loop mechanism in order to iterate that perfection, in order to arrive at a good model or a good decision point. And that's where some of the statistics, Bayesian operation, regression analysis, it becomes very familiar even for a scientist and engineer. And what we call automated machine learning, or the ability to do this autonomically or automatically, is really the key in the future towards accelerating science and discovery. So many domains are coming. So I introduced the term domain. Domain is essentially your application, whether it's health, whether it's manufacturing or materials development. You can introduce a lot of models and at the same time refine your algorithm in order to accommodate for the different variables or parameters. So more and more we will see AI machine learning going into manufacturing or advanced manufacturing. whether using the traditional manufacturing method or the advanced manufacturing methods using additive manufacturing or 3D printing, it will rely more and more on AI and machine learning to perfect or to optimize the system. Another is in energy. So traditional methods of energy extraction, whether it's oil and gas or it's solar or it's geothermal, which we have a lot in the Philippines, the more you apply AI and machine learning means you're going to have very good risk analysis, very good methods to optimize or make efficient the extraction process, or even optimize the production of energy and conversion to electricity or even your power grid. In fact, you will need a lot of energy when it comes to using AI and machine learning. And that's what you've heard in the news, that Google is investing on nuclear reactors. Imagine Google investing now on nuclear reactors. It's because they see a lot of energy needed for data. By the way, data is sometimes called the new oil. The new oil, okay? How important is oil? Well, we import most of it in the Philippines. But the new oil means you need drilling rigs, you need drillers, you need oilmen, okay? So I would say those of you who want to become oilmen, or those of you who want to get more data, get into that job, get into the profession of using machine learning and AI. And then lastly, with nuclear energy, it's coming. We cannot deny it, but nuclear energy, which is now in the form of microreactors or SMRs, is something that the Philippines is now open, especially with the agreements that are in place. And this is also another frontier for training. We will need a lot of nuclear scientists and engineers to get into this industry, which will win out us. By the way, France, Korea, they all use nuclear energy, okay? Japan, maybe not, Germany not, but as I said, I was just in France. France, electricity mainly comes from nuclear energy. 70% of the electricity in France is based on nuclear energy. So we will find AI and machine learning not only in manufacturing, but also in the supply chain. OEM production, different types of supply chain, blockchain developments, and actually you would see that in any manufacturing you need a good supply chain of parts and things to assemble. Military. So they've found that AI and machine learning, when applied to military, whether it's production or battlefield strategies and so on, is becoming very important. Again, because relying on data, satellite data, good data, they're able to plan to succeed in the military. Now, I'm almost closing the gap here. So at Oak Ridge National Lab, I lead a team that is focused on autonomic chemistry. How can we do automatic chemistry? How can we use AI and machine learning in order to synthesize new drugs or polymers or materials? So this team that I'm leading is made up of people working with computers, working with the chemistry lab, working with devising and designing instruments. So in this schematic diagram, we basically ask the question, if we have a particular target for a drug or a polymer or a material, how can we do the process of discovery such that we can optimize the design of that drug in the shortest possible synthetic scheme? Or how can we remove basically the trial and error process in a lot of production of materials? So in this concept, when we started this project, we wanted to remove the human in the loop. And in my experience working with AI and ML, you basically cannot remove yet the human in the loop. Probably it will take us 10 to 20 years. And the conclusions I'm getting is that scientists, chemists, physicists, engineers are still going to be in demand. The most important thing is you need to be the best in your profession. And you have to use AI and machine learning as a tool, okay? So using this scheme, we designed basically a lab reactor, a bench reactor using flow chemistry, We connected instrumentation that is tied up to an edge server. That flow chemistry allows us to bring the engineering in synthesis, meaning controlled pressure, volume, temperature, flow rate. So if we control the machine, we also have a monitoring process to get the data. We have a feedback loop mechanism that can be monitored or done iteratively using a local computer. We can run the whole thing, but it's not automatic. The human intervention is necessary. What if we have access to an exascale computer? Exascale means it's the fastest computer in the world. It's called Frontier. It's located at Oak Ridge National Lab. That means we can do real-time algorithm modification. That means within seconds, we get the answer on a new model or a new equation using the data coming from the edge server. That is, if we do the real-time experiment, if we do the real-time calculation, do we still need humans? Probably not, okay? So I'm warning you, some of you may have no jobs or lose your jobs in 5 to 10 years. But my prediction is it will take 10 to 20 years. So if you have this automatic, autonomic method of doing chemistry with access to exascale computing, maybe it's possible to augment reality with a system like this. But I actually call this a data miner. So as I've shown you here, if I can go back to the previous slide. Anyway, we can do this projects like this where we wanted to do a correct refractive index contact lens by 3D printing. We were able to do this autonomically using large language models and 3D printing by accessing some of this equipment. So tools like this, satellites, different types of data miners, different technologies that allows you to gather new data or mine data is going to be very important. That's what we need in the Philippines. We need a lot of data mining operation and access to technology that we can then convert and Philippinize. So if you do that, then you can uniquely apply it to Philippine problems and therefore take advantage of that technology. So in this case, this is how we demonstrated it. In fact, visually, as you can see here, these are elements where we have to use large language models like ChatGPT experience. In this case, our data is based on publication. So if we can distill, let's say, a specific set or subset of questions out of 5,000 publications and come up with the 10 best publications, we can immediately center our work on those 10 best fit publications. But what I'm finding out is that this is not as foolproof because like ChatGPT, how many of you have used ChatGPT? It works, but it doesn't work. Meaning it gives you something, but it's not really exactly what you want. And this is how we're finding out doing this type of exercise in chemistry. But because of the machine and the autonomic process we're building, we're able to clean up bad data. We're able to distill the essence of the true parameters. We're able to go around the noise. We're going to clean up all the data there, and certainly if you have this operation, you're able to create new data that's going to be even more valuable or quality data, okay? So in the end, we want to marry hardware, large language models, AI, machine learning, access to fast computing, and perhaps this is what we can call automatic or autonomic chemistry, okay? And we have been busy. We've been publishing, we've been demonstrating the concept, we've been using it for materials research as well in order to do projects. For many years, we are doing projects on 3D printing using different types of composite materials. On the average, it will take me about a year and a half to publish a paper with complete data. But we have been using AI machine learning. The average, 6 months. We're able to publish within 6 months. Good data, good work, and that just gives you the scale that even applying machine learning and AI in science or in your research, you can make do with more or of less graduate students. Okay, maybe that's a warning. Maybe in the future we will need less PhD students. But anyway, that is how fast the discovery process is. Now, we're not going to get away with PhD students and master students. In fact, we need them. We just need to retool them. We just need to lace their training with AI and machine learning. So I still believe the best jobs will be STEM field jobs. Sciences, physics, chemistry, material science, engineering, biomedical engineering, materials engineering, and so on. They're in demand. What we need to do is train them with the AI and ML domain. And I've been busy training Filipinos. This was a picture actually taken almost 15 years ago. I trained a lot of PhD students from the Philippines in my labs, in various settings, from visiting scholars to a full PhD program. Some of these faces might be familiar. Some of them are now professors, managers, laboratory managers, deans. Some of them might have been retired. But anyway, just tells you my passion. And in fact, going back to the Philippines has always been something that I like doing, whether it's as an ERDT fellow, balik scientist, fellow scientist, working with Institute of Chemistry, working with Giselle, and so on. This is something that I like doing, have been doing, and would like to do more. In many capacities, I've done this through field dev as a board of trustee, working with industries, working with different types of technopreneurship program, one that I led called the IDEA. But at the same time, we work a lot with DOST in terms of training our future scientists and engineers. And this, in fact, how we started AMCEN way back when I started the training of professors and experts in 3D printing and additive manufacturing. And we've been continuously doing this with BShared, that Dr. Paringit mentioned about investments in AI, in materials, and different types of programs with the SEI as well. So this is something we can do. And of course, I like coming back to the Philippines. So with that, I'd like to thank you and be happy to answer any questions later.